Hello, I'm Paco Muñoz. Let me explain the events module in Node.js. The goals of this presentation are to apply the operations of the events module in a correct way and to implement short programs with this module. The contents of this presentation are structured in this way. Let's start. JavaScript is an event-oriented programming language. This means that we'll need some operations in order to manage those events, that is, in order to generate new events and in order to process the arrivals of those events. In Node.js, the events module provides all those operations. So let's discuss that module. And to begin with, we should consider the documentation. And the official documentation for that module is available at this address. We should read all those explanations, but in our talk, we'll only describe the main operations in the module. There are many more, but they will be needed in other complex programs, not in the basic ones. So let's center our attention in the basic operations. And to begin with, we need to import the module. And the module is providing an object, not exactly an object, an element that behaves as a constructor of event emitters. So, what's an event emitter? An event emitter is the entity that may generate new events in a JavaScript program. And also, it may associate function listeners to each event. What's a function listener? One that is associated to an event and that will be run each time that an event occurs. So, in order to import the module, we need two lines similar to the following ones. So, we may read the events module using the required operation, and the returned entity is a constructor of event emitters. So we should apply the new instruction in order to create an instance of that class. Indeed, these two lines may be compacted in a single one, but using two lines, we may generate clearer programs. Well, let's consider now event generation. To this end, we should use the emit operation. In that operation, the first formal parameter is the event name, and it's mandatory. And subsequently, we may use many other arguments. Those other arguments will be passed in order to call the associated event listeners. But how many arguments are needed is a decision that should be taken by the programmer. Those events are emitted in a synchronous way. This means that when we call emit, all those registered listeners will be also called. And emit only returns control when all those associated listeners have been executed and their execution has been completed. So the listeners are immediately called and they are executed in the current turn. And indeed, they are executed before the emit operation returns control to the caller. Here we see an example of emit. We have used the previous two lines in order to build the appropriate event emitter, and now on that event emitter we may use the emit operation. And in this example, we are associating this argument in order to invoke all registered listeners for that event. Well, and in regard to listeners, we should associate a listener to an event using the add listener operation, or this shorthand for add listener. On is simply a synonym for this other identifier. And in this case, we need, again, as the first formal parameter, the name of the event. That's a string, simply. And as the second parameter, a reference to a function that will behave as a callback to be invoked when that event arrives to the system. There are no constraints on the number of arguments to be associated to those functions. It's a criterion to be taken by the programmer. And listeners are called in the order that they have been added. We may associate multiple listeners to the same event, and they will be called in the order of registration. Here, we are associating this function as a listener for the example event. So each time we emit example, this function will be called because process example is the listener for this event. Let's see a complete real example in this program. We are importing the events module, we are creating an event emitter, we are defining two event names, message and read, we have defined two global counters, 1 and 2, we are defining here a handler for the read event that simply shows this string on the screen, and this other function will be a listener for both events, message and read. And now here start the emission of events. Here, the emitter generates a read event and increases the second counter. But this has been made before any listener was declared to read, to the read event. So this emission, this event generation has been lost, hasn't been considered by any listener. Now we are setting the listeners for the message event that is using the all handler function, and we are also defining two listeners for the read event, all handler and read handler. And now, using setInterval, we are generating event message once per second and event read once every 2.5 seconds. Each time both events are generated, where we are increasing the corresponding counters. As a result of this, as we have already discussed, the first read event is lost. Why? Because it was emitted before any listener existed for event read. But no error or exception has been generated. Simply, this emit call is immediately returned, completed. And each time the read event is generated, we'll call all handler first and later on RD handler. Here, we are able to see the output, the first lines in the output of that program. As we may see, in white, we have the messages associated to the message event, while in light green, we may see the messages associated to the read event. As we may see, here we are generating once per second the messages for the message event. And later on, in green, we have generated the corresponding events of type read that are managed by two different handlers each time. And this concludes the presentation. Once this presentation is ended, the student should be able to apply the operations of the events module in a correct way and to implement short programs using this module.